When you talk about growth and decay, what that means when it comes to math is that it's like when you talk about bacteria growing. Okay, they always tell you how long it takes for bacteria to double. Okay, which means when you're talking about growth, if you're charting growth, if you're making a chart of growth, let's say bacteria doubles every minute. Doubles every minute. If you're looking at a chart, what does the chart of growth look like? Well, here's X is your minutes, and this is how many bacteria you start with. So let's say you start with one bacteria, at one bacteria. And then after, well, I guess, no, you can't start at 0. 0 would still be 0. Start at one bacteria, at 1, I guess. At the second minute, how many bacteria would you have? If they double every minute. If you double 1, you get 2. The third minute, you would have double 2, you get 4. The fourth minute, you would double that and get 8. The fifth minute, you double that and get 16. Let's make it keep going here just because. The sixth minute would be 32. The seventh minute would be 64. The eighth minute would be 128. The ninth minute would be 256. What does the chart of growth look like? First of all, is growth proportional? Is there a constant there? What do you multiply this by to get this every time? 2 times what is 2? 3 times what is 4? Same thing? For something to be proportional, it has to have a constant that works for everything. This is not constant because remember, proportion goes up in a straight line. If you were charting this, here at 1 you'd have 1. Here at 2 you would have 2. This is how many bacteria on this side. This is the number of minutes. If you have 3, it would be 1, 2, 3, 4. If you have 4 minutes, it's up to what? 1, 2, 3, 4, 5, 6, 7, 8. 5 minutes, it would be 8, 9, 10, 11, 12, 13, 14, 15, 16. Growth has this little chart here. It starts kind of slowly and then just keeps getting faster and faster and faster. So it's not a straight line. It's not necessarily proportional because you don't have that sort of thing. If you are looking at this, if we were trying to write, I guess they don't ask you to do this. What growth ends up being what? Between these two things, what do you do every time? You're multiplying by 2 every time, correct?
Yes.
So you're going to be looking for this. It's actually what we call exponential growth. Right? Because these are all really, if you look at these are all, those are all 2 to what power? If I was looking for a chart on how to do this, each one of these, right, is this not 2 to the first power? Is that not 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power? So how would I put up here what exponent goes with that? After the first minute, what did I have? A 1. 2 to what power is 1? 2 to the 0 power. So how do I go from this, which is a 1, to a 0? I know that's hard. If you have 1 and you want to make it 0, what do you have to do with it? Subtract 1. So here's the deal. To get my exponent, what do? I take my x and I subtract 1 from it. Does that work for 4? Is this number 2 to the x I take 4 minus 1, what do I get? Is 8 2 to the third power? Yes. Is 16 2 to the whatever power? Yeah. You are not gonna, they're not gonna ask you to do that. They are just going to give you problems that look like this. Find the next term in this sequence. Let's say you have this. Let's look at another growth term here. 16, 24, 36, and 54. Is that right? What would be the next three terms, and how would I figure that out? If this is growth. Anybody? That's right, I'll ask and answer as they say. You just need to know this. Growth is always the same common factor between each term here. So you need to know 16 times what number gives you 24. Because that's going to be the same thing, 24 times what number gives you 36. How would I find out 16 times what number is 24? David, yes, you would write an equation. I just said it. 16 times what number is 24? How would I find out what the letter N is? Divide by 16, divide by 16. Reduce that lovely fraction, it is what? 3/2. If you take 3/2 times the term in front of it, you're going to get the next term. So I take 54. What is 54 times 3/2? Now, 2 goes into 54 27 times. 27 times 3 is 81. What is 81 times 3/2? Oh, I can't cut 81 in half, can I? What's that? 243 over 2? That is the answer. Well, I guess they just asked for the next term, sorry. It'd be some goofy number here. Something like 121.5. Now, that's growth, children, and don't get all bonkered out about it. Just know that this is what you do. You have to divide the term by the term behind it to see what your constant ratio of growth is. Okay? If it's decay, it's the same thing, except you're actually going to multiply by a number that's smaller than 1. For example, here is an example of decay. 256, 192, 108. What would be the next number here? How would I figure it out? Well, you need to find out what this constant proportion slash constant is. You do it the same way. You have to ask yourself 256 times what number will give you 192. Done the same way. Divide by 256. Divide by 256. Hopefully that reduces down to something nice. Anybody know what it is? Take a wild guess. Brooke Kala? Yes, let's cut them both in half for Brooke. What is this? 96 over half of 256 is 128. Cut them both in half again, Brooke. What is it? Half of 96, Brooke? 48. Half of 128, Brooke? 64. Good. Half of 48, Brooke? Half of 64, Brooke? Half of 24, Brooke? Half of 32? Half of 12? Half of 16? Half of 6? Half of 8? Yeah, your common factor between all these is 3/4. If it's decaying, it is going, it's going down because you're multiplying by something that's less than 1. So what will my next one be? 108 times 3/4. 4 goes into that, what? 27 times is 81. Are those numbers, is decay going down slowly or more quickly as it goes past there? If you're looking at the difference in these numbers. Investigation here. Why does that not work? If you subtract these two, what do you get? 64? Subtract these two, what do you get? 84? Subtract these two, what do you get? Is that right? No, is this 164? No. What do you get if you subtract those two? 27? Why does this not seem right? Did I write the wrong number in the book? Oh, I did. No, I didn't. Yes, I did. No, I did. Yes, I did. I missed one here. There should have been 144 here. Sorry. That's why I was goofy. But it didn't change our answer because I missed that because we didn't use that one there. But this should have been. I was going to say that didn't seem right. What is this to this? 52. And then what was this to this? 36. 27. So it goes down slower and slower. Decay goes down slower and slower as you get farther away. Growth goes faster and faster. How many of you have absolutely no idea what any of that means? Look at, well, let me give you a piece of paper here. Let's see if we can't answer a problem. Here's the practical application. Take a look at this. Look at practice letter D. Practice letter D. How many I have? Have I got one? It says the number of bacteria in a culture increased from about 2,000 to 4,000 in 1 hour. Assuming the bacteria population grows exponentially, how much longer will it take the number to increase to 16,000? Sir?
2 hours.
Well, Ryan taking a blind shot in the dark, let's see if he's correct. Ryan, why would you say 2 hours?
Because in 1 hour it doubled, so in another hour it was
So Ryan is saying, let's actually look at this here. Let's make a chart. Because that's usually, you want to visually graph it there. What's it do? It went from what?
2,000 to 4,000.
Okay. It went from 2,000 to 4,000, which means every time it is doubling, right? That's our constant factor there. It went about 2,000 in 1 hour. So from 0 to 1, it went to 4,000. Alright? So after 1 hour was 4,000, right?
Yes.
So if you go another hour and you double it again, you end up with what?
8,000.
8,000. And at the third hour, it doubles again, you're at 16,000. So the question asked you, how much longer will it take the number to increase to that? Well, you started here. How many hours did it take? Ryan said? Did you say 2 hours?
Yes.
And there you have it. Ryan was graphically there. Look at letter C. Maybe I should let you try letter C. I should make you work in a group for letter C. The schools in an older community experienced a decline in the student population of 3% per year. If the decline continues at the same rate and there are 5,000 students in the community this year, how many students will there be in 3 years? Again, there's really no way to do this unless you kind of chart it all out. You've got kind of your X and Y. This year was what? 5,000, right? What is your constant factor? What's that?
3%.
3%. Now, here's where you have to think. It's declining 3%, right? And here's where calculation would be good. Is it not declining 3%? Is it going down 3%?
Yeah.
Yes. Okay, so if you multiply this by 3%, you're only figuring out what? How much it declines, correct? So you're gonna have to take that number. What is a different way, rather than multiplying by 3%, because if you multiply by 3%, you're not going to get the student population for the next year, are you? You're gonna get how much you went down. What could you multiply this by? Just like when you go into a store and the sale is 20% off. If something costs $100 and you're taking 20% away, are you only gonna pay $20 for that thing? No, because your 20% is what you're taking off, it's not what you're actually paying. If you take 20% off, what are you actually paying? What percent? If you take 20% off of something, what percent are you actually paying? If you take something that starts out at 100% and you're taking 20% off of it, how much are you actually paying? 80%. If something declines by 3%, what percent of it is actually staying? And that's where I would do. I would say, okay, I am multiplying everything by 0.97, and thank you very much. This would be the time when you'd say, Mr. Ron, I'm glad you let us use those calculators. Because if you take your calculator, that wasn't what I wanted. If you take your calculator and you multiply it by 5,000 by 0.97, where'd the calculator go? Huh? You take 5,000 and multiply it by 0.97.
What's going on?
Oh, that's what that thing is. How do I get out of there? Does anybody remember?
Yeah, what?
Huh? Well, I just took a picture of it.
Screenshot.
It
Is there a problem with that?
It is, because I can't do anything. Oh. Why is it? Oh,
I'll go to your computer and use the
I'll leave it
call.
on the picture.
Wait, did I multiply this by 0.97?
No.
It's stuck
See, it just took a picture of it. I am now looking at a picture.
Yeah, it's the.
David, hit escape on my keyboard. Will you? I knew I should have never pushed that button.
Escape.
Thank you. All right. Times 0.97. So now the population is 4,800. What was it? 850. What am I supposed to do this to? Until I get to what? What, after 3 years?
Yes.
And what year was this? This was this year. This is after 1 year. After 2 years, you'd have to take that new number and multiply it by 4,850 times 0.97. So after the next year, you're going to have 4,704 and a half kids. And then at the end of 3 years, you're going to take that times 0.97. And after the end of 3 years, you'll have 4,563 kids, and I hope that's right. Oh, round to the nearest 100. It's not cold. What?
It's just in a wheelchair.
Who's that? The one with the point, whatever? And then I said round to 100, so.
It would be a wheelchair.
No, it's one of those kid geniuses. Stop.
Decay, just transfer